Hello, Year 7. So you should now have completed your topic test on Unit 12, and as part of this lesson you are going to complete the DIRT activities. And what I'd like you to do is pick 3 or 4 questions that you are, or topics that you are not so confident with, and have a go at the questions on pages 240 and 241 of the usual book. Now I'm going to go through a couple of these questions to help you out. So the ones that I'm going to go through, I'm going to go through question 1A. I'm going to go through question 6. I'm going to go through question 9. And I'm going to do question 10A and 11A. Alright, so the first one, question 1A. Use a ruler and a protractor to draw these shapes accurately. So, the first thing I would always draw is the base of the shape. So, in this case, it's 56 millimeters. Well, 56 millimeters is 5.6 centimeters. So there's the base, and I'm going to label it as 56 millimeters. Now I'm going to use protractor. On the left hand side is an angle of 60. So on the left hand side, angle of 60 is there. Putting a little mark. And turn it up. It's always good to get into the habit of labelling. And then 40 degrees from this side. So your triangle should look like that. Now don't rub these lines out. That would be absolutely fine because your triangle is there. Okay, question 6. An octahedron is made of 2 square-based pyramids joined together at the base. The number of faces, vertices and edges. So if we look at the faces first of all, well, the top square-based pyramid has 1, 2, 3, 4 faces, and therefore the bottom must also have 4 faces. So it has 8 faces. Vertices are corners, so 1 at the top, 1 at the bottom, and then 4 round the middle part, so therefore it has 6 vertices. And edges, that's these parts here. So it has 1, 2, 3, 4. On the top square base pyramid, it also has 4 on the bottom square base pyramid, and then 4 around the middle, so therefore it has 12 edges. Question 9 then. So we're given a cuboid, it's 2 by 2 by 3. And we're asked to draw the net of this shape here. Okay. So I'm just going to do a really quick sketch. So that's 3 centimeters, that's 2 centimeters, and that's 2 centimeters. Not the best sketch, but it'll do. Right, let's draw the base first. So the base is going to be 2 by 3. So this doesn't necessarily have to be to scale, so I wouldn't worry too much about the scale. I am going to do it to scale, but as long as you label each part, that's absolutely fine. Oops. Sorry. So my squares are probably slightly different sizes to yours. So that's 3 centimeters. That's 2 centimeters. Alright, so that is the base. Okay, if we look at the left hand side, so this side here, again, that must be 3 centimeters by 2 centimeters, because this length and this length must be the same. And that must come off the left hand side of the base. So again, that's 3 centimeters by 2 centimeters, and that is the left side. Now the right side must be identical, but from the other side. So it must look like that again. 3 centimeters by 2 centimeters, so that is the right side. Right, the front, this part here, is 2 by 2. So 2 centimeters by 2 centimeters. So that's the front. The back must be exactly the same. 2 centimeters by 2 centimeters. So that's the back. And the only side that we've missed is the top. And the top must be again 2 by 3. Now this isn't the only answer, because for instance the top I could have put either there, there or there. I could have drawn the front and the back in slightly different places. But that's the way that I normally draw the net of a cuboid. Okay, part B. Oh, sorry, this was question 9. Not part B. Part B, calculate the total surface area. Or we can use the net for this. I'm just going to do it in red so you can see. The area of each face added together, so this is going to have an area of 6 centimeters squared. That's going to be 6 centimeters squared, 3 times 2. This again is 6 centimeters squared, so is this. The back and the front must be an area of 4 centimeters squared. So the total surface area is going to be 6 plus 6 plus 6 plus 6 plus 4 plus 4, which gives you 4 6s are 24 plus 8 gives you 32 centimeters squared. I'm not going to do part C. The reason for that is because I've done a very similar example in the lesson on how to draw this on isometric paper, so please just go back and have a look at that. Question 10a. Calculate the volume of the solids made from centimetre cubed. So that tells me each little cube is 1 centimetre cubed. So therefore we can just count them. So if we look at this one here, we've got 1, 2, 3, 4, 5 on the front bit, and then we must have 9 at the back. So 9 plus 5 gives you 14 centimetre cubed. Notice I've stated the units in my answer. Question 11. Again, I'm only going to do part A. So for each cube, I calculate the number of cubes in the top layer and multiply the number of layers by the total number of cubes. So let's set this out properly. So the number of cubes in the top layer, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the top layer has 10 cubes. So that is a volume. So yeah, a volume of 10 centimetre cubed. There are 2 layers of 10 centimetre cubed. So that gives you 20 centimetre cubed. So the volume is 20 centimetre cubed, which is effectively what the question is asking. Okay. So I hope you found that useful, and good luck.